Greeting to everyone. My name is Cardon Angeles, a student at the Technological University of the Mezquital Valley in Hidalgo. Today I will share our research with you, the design of a pelletizing machine for small poultry producers in Hidalgo, developed for the 20th International Interdisciplinary Conference on Renewable Energies, Industrial Maintenance, Mechatronics, and Informatics. In Hidalgo, 63% of households engage in poultry farming as their main activity. However, feed costs represent up to 60.9% of total expenses. That's why we propose an affordable technological solution for over 8,750 producers. To better understand this solution, let's define what a pellet is and how a pelletizer works. A pellet and the pelletizers. A pellet is a balanced feed compressed into a cylindrical shape made from plant-based ingredients. The pelletizer is the machine that transforms raw material into pellet using pressure, moisture, and temperature. Let's look at how we design this machine following international technical standards. We followed standards known, SEN, and IN+. We chose a rotating die pelletizer for its efficiency and simplicity. The proposed capacity is 350 kilograms per shift, using a mix of 60% corn and 40% wheat. To achieve this design, we considered several key technical factors. We evaluated production capacity, pellet size, feeding and discharge, system, motor and materials. We used high wear resistant steel and pressure adjustment mechanisms. Next, we calculated the hopper's useful capacity. Hopper capacity. With a radius of 12.5 centimeters and height of 22.1 centimeters, applying a 70% weight factor, we obtained a useful capacity of 7.59 liters. Feed density using FAO data 450 kilograms per cubic meter for corn and 750 for wheat. The resulting density was 570 kilograms per cubic meter. With this information, we calculated the main staff's rotational speed. We use a Pulley transmission ratio, obtaining a speed of 685 RPM, ideal for compacting without overheating. From this, we calculated the angular velocity. The angular velocity was 71.73 radians per second, allowing us to evaluate rotational behavior and mechanical efficiency. We also analyzed the volume and density of each pellet. Using standard dimensions and weighing a 50-gram pellet, the density was 442.44 grams per cubic centimeter. To calculate the breaking load, we first determine the contact area. The contact area between the roller and the feet was 0.0005 square meters, key for compaction pressure. With this, we calculated the breaking loads. Using a rupture resistance coefficient of 1 times 10 to the 7 pascals, we obtained a breaking load of 5,000 newtons. Next, we calculated the roller's friction force with a friction coefficient of 0.57. The required force was 2,050 newtons. With this data, we moved on the subassembly design. So assembly 1 is support number 1, and base number 2. The process continues with subassembly 2 and motor number 7 is here, gears number 1, chain number 2, drive shaft number 3, bearings number 4, and the plate or mold number 5, and rollers number 6. The design was divided into 3 subassemblies: support and base, motor, gears, and rollers, and finally the pelletizer chamber and discharge hopper. By integrating all components, we obtained a final design of the pelletizing machine. It's here. Discharge hopper number 1, pelletizer chamber number 2, roller adjust 3. As the components are integrated, resulting in the final design of the pelletizing machine, as shown in the picture. Chicken feed pellet machine, work capacity 350 kilograms per day, rotation speed 685 RPM, pelletizing system, compression using rollers and rotating G, transmission system, 1-hour power single phase electric motor with sprocket chain. Dimensions: height 0.5 meters, width 0.35, length 0.35, net weight 35 kilograms. Conclusions: this machine can help more than 80,750 small and medium poultry production in Hidalgo, generating an average of 350 kilograms of pellet per work day. The equipment is mechanically viable and capable of producing uniform, high-density pellets. Overall, this project contributes to improving profitability and self-sufficiency of local poultry farms through sustainable and accessible technology. The references: Fira 2024, Romero López Ana Rosa 2021, Hidalgo Gobierno del Estado 2023, Zagarpa 2012, Lor Mendoza Néstor 2016, Benke C. Kate 2010, De Lucía M 1993, Serway Ramont y Chewet 2008. Closing, we acknowledge Cier for giving us the opportunity to join the conversation and share our research. We'd also like to express our gratitude for the support of our academic institution, the Tecnológica University of the Mezquital Valley. Thank you very much. Gracias.